So let's take a look then at the first one here. 2 3/8 turned into a percent. A couple different ways we could go about it. We could make it a decimal because this one does divide out to an even decimal and then move the decimal point, or we could make it into an improper fraction and convert it that way. And that's how I would probably approach it. 2 3/8 becomes how many eighths? 19 eighths. So then we would set that 19 out of 8 would be how much out of 100? And we can cross multiply and divide. So 19 times 100 is 1900. Divided by 8 is 237.5. So that is 237.5%. The 0.094 is quite a bit easier. Multiply 100 or move the decimal point 2 spots and it becomes 9.4%. Any questions on those? Down here then, convert to a fraction. To convert a percent to a fraction, we always just put the number over 100. So it's 136 2/3 over 100. Now from there, we have a couple of things. First thing I would do is I would notice that it is improper. We have the larger numerator, so I'm going to take 100 out of it and have 136 2/3 over 100 left. Now to get rid of the 2/3 in there, I am going to multiply by 3. We still got the 1 up front. This is 300 on bottom. 36 2/3 times 3. Well, 36 times 3 is 108. Plus 2 is 110 over 3. 3's cross cancel, leaving us with just 110. Both of those divide by 10. Give us 11 over 30. So 1 11/30 is a fraction. Any questions? Okay, well, so we left off yesterday with those conversions, fractions to decimals to percents and so on. Today we're going to take a look, in the first hour at least, we're going to look at how do we calculate with these things. For example, so if blank is 30% of 70. Well, we've already said the percent is out of 100, so I always start with the percent. 30% is 30 out of 100. Now you have to have a number on the other side. Just like when we converted the fractions into a percent, we're going to set two fractions, or two ratios technically, equal to each other. So we have two other numbers in this problem other than the percent. We have the missing number and we have the 70. One of them has to match up with that 30%. Well, if we look at this, it says blank is 30%. Our missing number, the blank, matches up with the 30. So the 70 is going to go on bottom. You could also think of this as of 70. You could read it as out of 70, which also implies the 70 must go on bottom. So now to calculate, 30 times 70 is 2100. Divided by 100 is 21. 21 is 30% of 70. We could ask, what is 160% of 40? This is really an identical problem, just slightly set up differently. We have 160%, which is 160 over 100. On the other side now, we have the what, or the missing number, and we have the 40. What is 160%? So that missing number goes with the 160. Again, of 40, you can think of it as out of 40. That implies the 40 goes on bottom. Now, one thing we know about the result we're going to get here right now is it's going to be bigger than 40. How do I know that? It's more than 100%, which means we're going to have something bigger than what we started with. This 100 down here is actually also can be thought of as a percent. 100% is the whole thing, or the starting amount. So when we look at this, the 40 is the starting amount, or the whole thing. And what we're going to get is based off of the 40. So 160 times 40 is 6,400. divided by 100 is 64. So 64 is 160% of 40. So on this one, 80% of 20 is blank. So we still have the percent. 80% is 80 out of 100. Now we have the 20 and we have the missing number still. Which one goes where? Which one goes on top? Well, this is of 20, right? So think of that as out of 20. Implies that one goes on bottom. And if we read it leaving that piece out, 80% is blank. Makes sense, doesn't it? So the 80% matches up with the missing number. And the out of 20 goes on bottom. 80 times 20 is 1,600. Divided by 100 gives us 16. So 80% of 20 is 16. $32 is blank percent of 80. Here we're looking for the percent. Now, I've been telling you that we always start with the percent, but here we don't have it. But that doesn't change anything. I'm still going to start with the percent. It's just blank over 100. Now on the other side, we're just matching it up again. 32 is blank percent. The 32 matches up with the missing percent. Of 80 or out of 80 implies the 80 goes on bottom. So once again, we cross multiply and divide. Even we're cross multiplying in a different direction, but it's still the same process. 100 times 32 is 3,200. Divided by 80 is 40. 32 is 40% of 80. %. So now we have 63 is what percent of 90? So again, we're missing the percent. So it's blank over 100. But the 63 and the 90, which one goes on top? 63. 63 is what percent? Then, of course, the 90 goes on bottom. Think of that again as out of 90. 100 times 63 is 6,300. Divided by 90 is 70. So 63 is 70% of 90. Once again, set up a little different. Follows the same process. Blank percent, well, we're missing the percent, so blank over 100. Blank percent of 150 is 60. But the 150 and the 60, which one goes on top? Blank percent out of 150. No, that's implying probably on bottom for the 150. Blank percent is 60. The 60 is going to go on top. Notice the difference between the wording there. 63 is blank percent of 90, blank percent of. Now, some people will teach you is over of. So 63 is, that goes on top of 90, so that goes on bottom. And for these simple problems like that, that usually holds true. I'm hesitant with that, though, because we can get into some of the word problems where that isn't necessarily true. So anyway, we'll cross multiply and divide. 100 times 60 is 6,000. Divided by 150 is 40. 40% of 150 is 60. So here, 24 is 60% of blank. So we have the percent again, 60 over 100. Does the 24 go on top or bottom? Top. 24 is 60%. It goes with the 60. So we're still cross multiplying and dividing, but once again, we're going in a little bit different direction. 100 times 24 is 2400. Divided by 60 is 40. 24 is 60% of 40.
You like the ending in 40?
What's that?
You like the answer 40?
I've had a few of those, haven't I?
Really?
I'm just picking out numbers as I make these up that happen to work out easily. And 40 seems to come up a lot when you do that. So 35% of blank is 28. So, again, 35%, 35 over 100. We have the missing number in the 28. Which one goes on top? 28. 35% is 28. Out of blank means the blank goes on bottom. Cross multiply and divide. 100 times 28 is 2800. Divided by 35 is 80. 35% of 80 is 28. So that's our basic calculation with our percents. Now you notice I use this proportion. Some of you may have learned other methods of doing this. In fact, a very common method is called the rate method of percents. And the rate method of percents is where you take all your percents and turn them into decimals. I'm going to go back and show you this. I prefer the proportion method just because I found people make a lot less mistakes using the proportion. And when it comes to problem solving, it actually works really neat. And I'll show you that in a couple minutes. But let's go back through these problems here again and use the rate method. So here, blank is 30% of 70. So 30% is turned into a rate of 0.3. And then to solve that, I would do 70 times 0.3 is 21. I get my answer. Well, that seems really slick and quick. How about here? 160% would be 1.6 as a rate or a decimal. Take 40 times 1.6, I get 64. Again, I get the right answer, and it's really quick and clean, which is wonderful until, scroll down a few here, I get to one like this. 60% is 0.6 as a rate, but I'm not going to take the 24 times 0.6. I'm going to take it divided by 0.6 to get 40. So if you use that rate method, you have to be able to decide, am I going to multiply by the rate or am I going to divide by the rate? And you run into a third possibility, which is this problem here. When you're not given the percent, to find the percent, you take the two numbers. This one will be is over of again, basically. 60 over 150 divides out to be 0.4. So now you have to move that decimal point to make it 40%. So with the rate method, you have a couple of decisions to make. First of all, you have to decide, do I move the decimal point first, or do I do my calculation first and move my decimal point at the end? Second, you have to decide, if I do move the decimal point first to make a rate, do I multiply by it or do I divide by it? Like I said, that rate method causes a lot more mistakes. If you were taught that way and you're good at it, this is how I do most of my percents. That's how I can do them quicker. And that's how I make up the examples that I use in class very quickly. But at the same time, if you're not very, very careful, it makes a lot more mistakes than using the proportion. The proportion is always, once you put things in the right spot, is always cross, multiply, and divide. You don't have to worry about, do I divide, do I multiply, do I whatever. It's always cross, multiply, and divide. The other thing I like about the proportion is it helps us when we're doing word problems. For example, let's say that, Tim's Corporation estimates that profits are 12% of gross monthly sales. Find gross sales for a month when estimated profit is, let's see here, $37,200. So just like with our other problems, I start with my percent. I got 12% here. 12 over 100. Now we have to define what each of these numbers stands for. 12 represents what? 12%. But what is the 12%? We have two things. We have the profits. We have the gross sales. Which one is being represented by the 12%? Profits. Profits are. R is just a different variation of the word is. Profits are 12%. That's the profits. This says of the gross monthly sales. So it's based out of the gross monthly sales. So this is gross sales is the 100 represents that. Because remember, the 100 represents the whole thing or the starting amount. Once I've labeled that, now on the other side of my proportion, the 12 represents profits. The 100 represents gross sales. Do I have the other number for either of those? Well, I have the $37,200. Does that represent profits or gross sales? Estimated profits. So that goes with the profits. And that's the key to these proportions, is this number and this number have to represent the same thing. They both have to represent profit. So now to find that estimated gross monthly sales, I'm going to cross multiply 100 times 37,200 divided by 12. What do I get? 310,000? Not so bad? Let's do another couple of simple ones here. Let's say you receive an 8% discount. What is the full price on a purchase where you receive a discount of $18.72? Okay. You guys kind of look at this, pick it out. In fact, let me give you about 2 minutes or so to try it in your notes, see if you can get everything set up, and then we'll talk about it. Okay, so setting this up. We have the 8%, 8 out of 100. I'm just going to jot in here a quick little label. What does the 8% represent? The discount. 100 would represent full price. Now it's very important that we label even the 100. And it's tempting to just label the 8 as the discount and go from there. But I'm going to show you in my next example why that is so important. What goes over here then? 1872 goes on top. So then we'll cross multiply. 100 times 1872 divided by 8 is 234. $234. Perfect. Now I mentioned it's very important to label what the 100 represents as well. And let me show you why. Let's say you receive a 6% discount. What do you pay on a purchase where you receive a discount of $14.68. So if I set this up, 6%, what's the 6 represent? Discount. What's the 100 represent? I mean, I might be looking through the problem and say, oh, the amount you paid. But what does the 100 always represent? The full amount or the starting value. And in both cases, that would be the full price. So we're looking at here, we have the discount, the $14.68. We can use this to find the full price. We cross multiply and divide, and we're going to get $244.60. But that's not the number we're looking for, is it? We want to know what we paid, and you're absolutely right. We have to subtract. $244.60 minus the $14.68, which is going to give us $229.82. That is the amount we actually paid. Does that make sense? So you can't just look in the problem and say, hey, the problem is talking about a discount and the amount we paid, and just assume that those are the two things represented by the percent, because in this case, they're not. Any questions on that one? All right. Now, this is a problem where we're dealing with a percent decrease, and there are other problems where we have a percent increase. And we have problems like that. There are actually three things that are being represented. There is a starting amount, starting or beginning amount, then plus or minus some sort of an increase or decrease. And then there's an ending amount. There's three values being represented. Now, a percent itself only represents two out of those three values. So to make sure we represent all three of them, when I'm dealing with a problem like that where we're having an increase or a decrease, a discount is a decrease, a markup or something like a tax would be an increase. When I'm dealing with those percent increase or decrease problems, I actually set up a little table. It helps me organize the information, and it allows me to represent all three values at the same time. Let me show you what I mean. For this particular problem, it would look something like this. Oops, that's the wrong problem. Oh well, we'll just rewrite it. How's that? Some days technology is not my friend. 6% discount. Discount is $14.68. Find amount paid. You guys can understand my shorthand, right? So what I do is I like to actually, and I do this is a problem-solving strategy I do on a lot of word problems. I actually write out in words the math that is happening in the problem. So here we have some sort of a starting amount or a full price. I'm just going to write it as full price. What you use for this label doesn't matter. The words don't matter as long as you know what it means. It's the price before the discount. You can put before discount or full price or starting price or whatever you want to use for that word. It's what it represents, and as long as you know what it represents, that's what matters. And here we're going to subtract a discount. Again, you could write subtract a decrease or whatever. And what we're going to get is the amount paid. And again, you could put down price after discount or whatever you want to do, whatever words you want to use, as long as you know what they represent. Now, in any sort of a percent problem, all of those amounts are represented by two different numbers. They're always going to be represented by a percent, and then they're going to be represented by, in this case, a dollar amount or some other sort of an amount. So it's a dollar amount in this case. So if we put in what we know, we have 6%. That represents the discount right there. On the other side, we have the $14.68 represents also the discount. And looking at this, it appears that that is all the information we have, but it is not. In a percent problem, we always have the 100. And 100 always represents either the full amount or the starting amount. The starting amount, full price, is represented by the 100%. And now because of that, there's another number we can get really quickly. Because it's full price minus discount equals amount paid. That applies on both sides. 100 minus 6 is 94. The amount paid is 94%. Now what are we looking for here? We're looking for the amount paid. So we don't really need the full price up here. Why did I keep the discount and not the full price? Well, because the discount I know both numbers for. So I need to have one value that I know both numbers for. And I need the other value to be the one I'm looking for. And now with those two values, I can solve this problem. I could set up a proportion if I wanted to, or I can just cross multiply and divide right in this table. 94 times 14.68 divided by 6 is 244.60, right? What do you think? 66? Was it?
Yeah.
All right. Oh, 67 you mean? Gotcha. 244.67. There. Now this table takes a few minutes to get used to, but once you're used to it, it really helps to set up problems. Now we just saw this problem here we could have solved using what we did up here, and it would have worked fine. But there are problems where we can't do that. We can't just do the percentage and do some subtraction to find the amount we're looking for, because we run into a problem like this. After a 14% discount, you pay make this work. $387. What was the full price? Or what was the price before discount, however you want to word it. So we'll set this up. We had full price minus a discount equals the amount paid. Again, we have a percent, we have a dollar amount. What do we know? So you know the amount paid is $287. Do we know the discount here? Other side, no, 14% is over here, right? We know the 100% is the full price. And from that, we can very quickly find this amount is 86. 100 minus the 14. We're looking for what is the full price. We're looking for this number right here. So I'm going to not use this middle row this time. And I'm going to cross multiply 100 times 387 divided by 86 is $450. What do you think? Not horrible? After a 13% price increase, the new price is $452. Find the amount of the increase. So again, we have an old price plus an increase equals a new price. Now what's slightly different here from what we've seen so far? All these others have been a discount or a decrease. This is an increase. Still percents here, and then once again, sometimes it can be other amounts other than dollar amounts on the other side. It's still dollar amounts for now. So if the 13% is the increase, 452 is the new price. What else do we know? No 100%. And what do we fill in down here? Is it 87? Say no. It's an increase, so we're adding it, 113. We are looking for the amount of the increase, the dollar amount of the increase. We're looking for this number here. That's the top row we don't need. So 13 times 452 divided by 113 is $400. Oops, no, 52 bucks, sorry. 52. 400 is the original amount, the old price. What do you think? We'll try to get some time in the second hour to do some more examples of the increase and decrease problems like this. For right now, I'm going to have you, this is in the big book. I'm going to have you look at page 171. It's exercise 5-6. Page 173. Exercise 5-7. Page 175. Exercise 5-8. These are just the simple little sentence problems like we started out with. And of course, just do the odds again. And then on page 172, exercise actually, no, this should be included. This is actually page 172 that this starts on. This starts on 172, and this actually starts on 174. Page 176 is the other one I'm looking for, which is exercise 5-9 that has more word problems in it. So again, just work on the odds. I'm going to give you the last 8 minutes or so here of our first hour to work on these. We'll take a break, and then we'll come back and we'll talk a little bit more about them.